Hello, my name is Ryan Horn. I'm excited to present my 3-minute thesis to you, titled Improving Cochlear Implant Function and Integration by Photograftable Thin Film Coatings. The cochlear implant is an amazing device. It uses an outside sound detection mechanism to communicate an electrical signal into the inner ear to directly stimulate the nerves that go to the brain to produce the phenomenon of sound. However, a cochlear implant has a few disadvantages in its function, and they have to do with scar tissue formation in the inner ear. And these can be caused by two different mechanisms. One is from the insertion trauma, from the initial placement of the cochlear implant in the inner ear. And the second is from the presence of a foreign material in the inner ear. My lab works on preventing these two mechanisms for producing scar tissue by placing specialized thin films on cochlear implant surfaces. I show here an image of one of these thin films highlighted in blue, stained in blue, against a colorless region of the cochlear implant which hasn't had the thin film applied. What these thin films are made of is they're made from a process that uses UV light to photograph the thin film to the cochlear implant surface underneath. This process is called photografting. The thin film works by two different mechanisms to reduce scar tissue. One is by blocking the sticking of scar-building proteins on the surface. When we compare standard cochlear implant materials to thin film photografted materials, we see that the scar-building proteins are dramatically reduced in their ability to stick when we have a thin film present. We've also seen that when we put a thin film onto an actual cochlear implant and measure how much force is required to insert it, we only need about half as much force, and therefore can produce a lot less trauma because the thin film causes a lubricious and slippery surface, making for frictionless insertion, or reduced friction insertion. Thus, there's amazing potential for these photograftable thin films to improve cochlear implants, and also a lot of other implants, through preventing protein adhesion and also by reducing insertion forces. Thank you for your time, and I hope you can see my poster.